So let's start working with task 4 now. Here we are given some linear equations and we have to solve these by using Naive-Gaussian elimination to find the values of x1, x2, x3 and x4. So if we first write it down in the augmented matrix form, here we'll get the matrix that looks like 3 minus 2, and we have minus 7 and 6, and in the B side, the vector B, we have 80.5. Be very careful when you write the matrix down, because not always you will see these all organized. So for the first one you have x1, x2, x3, x4 organized, but then here we do not have x1 in front. Here we have x4 before x2 and x3, and here we have x3 before x2. So you have to be very careful. So when you're writing for the last one, you have to write x2 first before x3, right? So some of you get confused in these also. Be more careful in these regions. And then here we have 0, 0, 0, 0. We don't have any more x1 values. So then we have 5, minus 1, 2. And here we have minus 2, 3, 11. And here we have 1, 1, and 9. For the vector B, we have 44.6, minus 22.2, and minus 52.4. So first, what we're supposed to do here is we're supposed to freeze the first row, and then we're supposed to make all the elements below the first row, first column element, all the element of column 1, we're supposed to make them zeros. But here it's already 0, so we don't need to work with the first matrix. We have to directly go to work with the second matrix here. So we are directly working with this matrix here, okay? And we will freeze the first row here. So let's freeze this here, and then we will make all the elements below the first column, first element. These elements here will make them 0, right? So as you know, this one here is L32, and this one here is L42. So let's find out for L32, the value will be A32 divided by the element here in the first column, first row. So here that is A22, so that is minus 1 divided by 5, and for L42 it will be A42 divided by again A22, the element of the first row, first column, which is freezed by us. So here now we have 2 divided by 5, right? Now we'll take these numbers here for L values and we'll write row equations here. So here we have row 3 minus L32, which is minus 1 over 5 times the row that we freezed, row 1, and the calculated values we'll put it in row 3. And again for this one here we have row 4 minus L42, which is 2 over 5 times, okay, the freezed row here is not row 1 but row 2. So yeah, this is row 2, and the calculated values we'll put it to row 4. So once we finish our calculations for these row equations, we'll get the matrix that looks like this. So we have here 3 minus 2 minus 7, 6, and here we have 80.5, and we have here our zeros. So now we write the row that we freezed, so that's 5 minus 2, 1, and here we have 44.6. So now we worked out on this one here, so these are zeros after the row operations, and here we have 2.6, 11.8, 1.2, and 8.6 here, and here we have minus 13.28, and here we have minus 70.24. Okay, now we will work with our next matrix, which is this one here, and again we will freeze the row 1 and we'll make the first column all elements below the first element to zeros, and this one we know is L43. So L43 is equal to A43 divided by A33. So we divided by the first element in the row that we freezed. So we have here 11.8 divided by 2.6. And now using that, we'll create our row equation for the row 4 here. So we have row 4 minus L43, which is 11.8 divided by 2.6 times the row that we freezed, which is row 3, and our results we'll put it in row 4. So after you finish your calculations now, you will get the matrix that looks like this here. So you have 3 minus 2 minus 7, 6 here, and 80.5, and then you have 0, 0, 0, and 5, 0, 0. Then you have here minus 2, 1, 44.6, and here you have 2.6, 1.2, and minus 13.28, and here you have 0 and 3.154, and here you have minus 9.97. Okay, so once we have come to the upper triangular form here, we can now directly work it out. So from the using backward substitution from the last line here, we can start working out. So we'll have 3.154 times x4 is equal to minus 9.97. So we have x4 is equal to minus 3.161. And then for the next equation, we have 2.6 times x3 plus 1.2 times x4 is equal to minus 13.28. So instead of the x4, we will use our value that we have received for x4, and that will give us the value for x3, which is minus 3.649. And then the next equation, we have 5x2 minus 2x3 plus 4 is equal to 44.6. So now we'll replace our value here with x3 value that we got and our value here with x4 value that we got, and that will give us the value for x2 as 8.09626. And then here we have the last equation, which is 3 times x1 minus 2 times x2 minus 7 times x3 and plus 6 times x4 is equal to 80.5. And after that, if we replace x2, x3 and x4 with the values that we already received, we'll get the value for x1 is equal to 3.036. So yeah, you can write your solution vector x as 30.036 and 8.0926 minus 3.649 and minus 3.161. That's the end of task.